Hello. I wanted to go over a couple of problems for you. Number 4. And this is in Chapter 7, the mean. The first part, which you do have right, it's just asking for your mean and your standard deviation of the group. So the mean was the 163,000, and the standard deviation was the 30,000. Now, when you have a sample, for a sample, the mean stays the same. But the standard deviation is the previous standard deviation divided by the square root of the sample. So it would be 30,000 divided by the square root of our sample, which was a simple random sample right here of 7. So it's the square root of 7, which will give us that 11338.9342. Okay. For part C, C says for a single random sample, find the probability that the salary is between 161,000 and some and 1,706,000. So they want them between those two values, this one and this one. But it doesn't say a sample. Notice the second one says a sample of 7. So this one doesn't say the sample. It's using the mean and standard deviation from part A. So you use the normal CDF, the smaller value, 161692. Don't put the comma in the number. 176,961. And then your mean and your standard deviation. Don't put the comma on the number. So if we go under distribution, second and distribute, and it's the second one down, and then you put 161692, comma, 176961, comma, 163123, and the 30,000. And you get their answer right here. Now the only thing different in part D, because we're going between the same two values, but it's the sample of 7. So it uses these. The mean will be the same, and the only thing that changes then is the standard deviation. So all our numbers will stay the same except the 30,000. So to change that, you could hit second and enter. It brings the problem back up, and then you just change your 30,000 to the 11338.9342 and hit enter. And that's this one. Okay, let's try number 10, because I think it was 10 covers a lot also. Yeah, because it's got the quartiles also. Number 10, we have a mean for the part A of 8.5 and a standard deviation of 1.6. B is the lowercase, it's a sample. And this one, the sample size is 10. 10 randomly selected large cities. Mean doesn't change, 8.5. But the standard deviation is 1.6 divided by the square root of 10. And 1.6 divided by the square root of 10 is 0.506. For part C, it says, what's the probability that a random selected city waterway will have more than 8.7? So we will use the same normal, but notice they're only giving us one value. We want from this value and larger. So when we use our normal, our lower value is 8.7. The larger one, just put a lot of 9s, make it very large. 9, 9, 9, 9, 9, 9. If it was the other way around and it was below this, then you'd use a negative 99999. And so it's that, and then this one was not the sample, so it was the 8.5 and the 1.6. And if you plug that into the calculator, under distribution, second distribution, and it's the second one down, and then it's 8.7, comma, bunch of 9s, comma, 8.5, comma, 1.6. And there's this one. Part D is doing the same thing, but it's a sample of 10. Because it's the sample of 10, the only thing that changes is that standard deviation. It changes to this. So you can hit second and enter, and then your 1.6 changes to a 0.506. Oops, I hit it twice, but and there's your value right here. I think you understand the E's because you're getting all of them right. For F, it wants the quartile. Now you have to remember when you do your quartiles, this is Q, they use 1 or L, 1. This is Q3. And then when you find these two, I, Q, R is just subtracting them. But what they do, and the median is in the middle, it breaks these into 25%, 25, 25, and 25. So to find this, 25% of the data is below it. It's the 25th percentile. Now in this one, we're doing the reverse. Instead of finding the percents like we did here, we're finding the number given the percent. And so that one, under distribution, it's the norm, inverse norm. It's the third one. For the inverse norm, you need to put your percent below 0.25. Then your mean, which was 8.5, and your standard deviation. mean 8.5, standard deviation 1.6. So we bring that up. We put our quarter, 8.5 and 1.6. And that gets us our, whoops, did I put in wrong? 0.25, 8.5 and 1.6. Maybe you don't need the decimal. Nope, you need the decimal. Okay, so if it was from the whole sample, it would be 7.42, but I didn't notice this says the 10 cities. So you want to watch for that. Because it's saying the 10 cities, we use part B, which means the other standard deviation. So if we hit second and enter and bring it back up, if we change this standard deviation to the 0.506, the one for the sample, then we get the 8.15. So be careful of that. Some have the city and some have the sample size and some do not. So that would give us this one, 8.1587. To find this one, notice it starts here and it's everything below it. So Q3 is a 75th percentile. So this one was the sample of 10, this one was the population. Now for the 75th percentile, and again it said the sample of 10, this would all be the same except you change your percentile. .506. So I just need to go in and change this to a 7. So I can hit second and enter, and then change that quarter to 75. Then you get your 8.84, which is right here. The last one, you just subtract these two answers. So you take this 8.84, 8.841. Okay, see how the numbers are different a little bit? Well, that's the difference in using the calculator and the Excel file. Because I have a 1 and... oh, that would be a 3. They want one more decimal place. They want 4. These could be off a little bit depending on what program they use. So if your decimals are off a little bit, let me know, because I'll go through and check all of them and give you credit for them. But when we subtract it, 8.1587, then you get the 6826. So it was just subtracting them. But I will go through, because these could be 100th or 1/10 of a decimal off, and I will give you credit for those.